Welcome to Solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
So, problem set: predict a likely mode of decay for each unstable nuclide. So, we are going to use the periodic table method to do this. This is Sb antimony. What this basically does is you check for the atomic mass of antimony from the periodic table, and that is found to be 121.76. And then you find the number of neutrons and protons in each. And you can, when you do that, you realize that there are more neutrons in the Sb-132 compared to that of the 121. So what would basically happen will be a conversion of the neutrons to protons, and this is what is referred to as a beta decay. So you just have to do the math and then you are good. So for the second element is tellurium 139. Also, so when you check for the atomic mass is 127.60. So finding the number of neutrons and protons in the radioisotope, that's the 139 and then the 127.6, you realize that there are more neutrons than protons in here, so there will be a neutron to proton conversion in a beta decay. So the next question is francium 202. The atomic mass of that on a periodic table is 223. For this one, you can see that our radioisotope is very light compared to that on the periodic table. So it means we have more nuclide. We have more neutrons in the 223 than what we have. So our radioisotope is likely to undergo electron capture or a positron emission and basically give you the same results. So this converts protons to neutrons, since you can see there are less neutrons in here compared to what is on the periodic table. So that is a positron emission or electron capture. And we've already covered this in the previous problem set. So the last one is barium. And the mass number is 123. From the periodic table, we find that the mass number is 137. So yeah, this is also a light nuclide. And so there is less neutrons in there compared to the proton. So this will be the same as this. And then there will be a positron emission or electron capture right here too. The results will be the same, but just in one case there is capture of electron, in the other there's the emission of